Hey guys, welcome back. It's your boy Loki, and we share tips, tricks, insights about AI and different tutorials and hands-on practical insights on how to use different AI tools, different open source libraries, repositories, and of course plugins and agentic skills in Cloud Code, in Codex, in development. And today we are discussing about something which is very important and very crucial, whether you are a solo founder, a developer, or you are running a SaaS startup and agentic SaaS full stack application. And the major concern is about how to optimize and control the costs because, as you know, guys, OpenClaw the insights have shown us that when you run a single agent on OpenClaw, it costs you around 300 US dollars on monthly basis. A single agent, just tag them and you got yourself a chunk load of expense right then and there. So it is very important that we have observability, we have analysis, and we can track what is costing us so much, and we can cut down unnecessary costings and token usages to optimize and efficient and make our solutions efficient. So today's agenda is LLM ops. So without any further delay, let's get started. As you can see, I have three main motives: observability, versioning, and analysis. And I've prepared a document, a kind of six-step playbook where I will walk you through and how we can actually utilize this. So in practice, LLM op means instrumenting everything so you can monitor quality and cost, version changes safely, and canary test updates and set budget controls before disaster strikes. So what is LLM ops? Traditional APM LLMs have new headache, inducing failure modes, unpredictable hallucinations, sudden cost spikes, trips, and security gaps. A model that passed offline tests can still go rogue when hit by real-world prompts. And old APMs doesn't do well. So you have to have logging mechanisms for prompts, responses, latencies, token usage, analytics. So you don't have to do everything manually. Observability, build your monitoring stack, which basically has your GPU CPU usage, prompt text with hash IDs, and an LLM pipeline. Don't worry guys, I have got something very useful for you guys. I have created a skill. Yes, I've created an agentic skill which have every instruction, every step, libraries to use, and environment variables pre-configured, which you can use with Cloud Code or Codex, and you can actually tell your agent that this instruction of LLM ops has to be followed while orchestrating any kind of AI full stack application or agentic orchestration. So I will show you guys that also live. Just we can go with this. Datadog's LLM observability lets you break down an real OpenAI spending down to each trace and prompt. True Foundry's AI gateway similarly act as a single pane that tags each request with user and team and logs token usage, latency, and model name. These logs feed dashboard and alerts, key metrics like app level metrics, mode level, model level, infrastructure level. So these will give you a visibility and which system prompt and instruction is giving you best output, keeping the tokens optimized. One such thing is OpenAI caching, or basically caching mechanisms, where you cache certain responses, and whether if some similar query comes to your API endpoint, the cache is used so the token usage is reduced to answer that respond or to respond that query. So then CI/CD pipelines for prompts, automated evaluations, and some small regression tweaks. So you know what is unrelated, what needs to be cut down, what needs to be efficient, or what kind of prompt strategy you have to use. There is a zero shot prompt strategy, prompt chaining. You have to use delimiters. Some eval parameters becomes continuous QA in production, which is automated. Cost tracking and controls, FinOps, set budgets and alerts like your wallet depends on. So similarly, the LLM ops checklist instrument everything: log prompts, responses, latency, baselines and alarms, track latency, error rates, hallucinations, version control, and model settings in a Git or registry. Track versions immutably, so you can roll back to exactly what worked before. It helps reducing a lot of cost and a lot of you can say unnecessary spendings on the whole infrastructure, budget guardrails, so it automatically alerts you. You can like there is one project in which I had to build a CLI tracking system where actually we were tracking how much usage has been done by a teammate using Cloud Code, which was like it really helped us a lot by tracking where we need to cut down some testings, or where we need to make sure that when we are using Cloud Code, these kinds of tasks create a lot of spike. So we need to make our prompt efficient, or we need to structure it in a way that it doesn't cost much or use some external agentic scale. So this task is reduced, or the load is reduced on Cloud Code for that particular task. And these are some references. Don't worry guys, I will share you the link of this post. I've posted this on my LinkedIn also. And without further ado, let's get right into the can say our Windows system. So yeah, now we are on our ABS. I try to keep things more raw and real, because I know guys it is very hard to understand these kinds of thing, and I want you guys to see uh, what we are doing. And this is, I trust this folder. As you can see, I've opened a fresh Cloud Code environment, and I should hide this. This folder is empty. This has an env file, and this is LLM ops agent skill. So it has table of contacts, project root, layout structure, observability, inference, LLM response, JSON responses, YAML files, instructions, JSON responses, evaluation parameters, native dashboards, configuration files, and everything properly. What are the metrics? What are the models? And yeah, pretty much everything is pre-configured here. What I have to do is just, let's say, I want to build an agentic orchestration which takes YT transcripts and repurpose them into short form content. Use the LLM ops agent skill while you are doing the orchestration for proper LLM ops. And this need to be done in Python. So irrespective of let's say Python or Next.js, it is easy. Like it can be used. But here I will be using Python because it is easy. You can do it in Next.js also. In preferably you can use this in Next.js applications, because in Next.js applications you have more control over your database pipelining and a lot of libraries and frameworks. In Python, mostly we do the orchestration part. At least I, from my perspective, you guys, of course, and also you can use this skill file in Claude Code and in GPT Codex both. So I will give you this skill file after. You can find this in my community tab or in a Drive link. I will share that link in the description also. And yeah, let's click enter, and it will go through this LLM ops agent skill, and let's see what it does. So it is using my superpowers brainstorm skill, and then it will go through this skill, explore the project context, ask clarifying questions. Yep. Cool. So it can take a little bit of time, and yep, this task is tedious. I know. It will explore all the projects, it will ask you clarifying questions, bunch of questions, then it will propose you the architectural design, then it will validate. So it kind of takes like up to 15 minutes. It takes sometimes to just get you the things. What type of short form content should the pipeline proceed with? I'm just going with random things. It doesn't matter to me right now. How should the pipeline receive YouTube's transcripts, fetch transcripts via YouTube transcript API, raw text inputs, whatever, man. Let's do it. Let's say we do via YouTube transcript API. Okay. For Twitter X thread output, what's the target style? Educational, operated, hot takes, bold claims, storytelling. Let's say B and C, both. Cool. How many tweets per thread? Let's say A. Doesn't matter right now. One thread, 5 to 8. Question 5. How should the agent be invoked? Pit 1. CLI tool endpoint returns thread as a JSON or both. Let's say we have both. Doesn't matter. What Claude model should power this? We have both Claude and Open Router keys available. Use Open Router. Let's say we are using Open Router. And yep, we are right now on LLMs checklist. We have to first instrument everything properly for the LLM ops dashboard. Let's see LLM ops dashboard. Now we got on preferences, instrumentation. It has gone through this and now it will use this as a skill natively to uh, do the things accordingly, code things accordingly. You are using another skill, brainstorming skill, but it is natively using this as a base point to keep this in mind that whatever it does, it has to be in line with the operations. So let's say we go with B, simple HTML JS frontend on port 3001, fast API, backend with CLI dashboard, blah, 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 blah. Optional linear chain sequential pipeline unit transcript blah, 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 blah. Sorry guys, it is just too much of text. I'm not seeing anything. I'm just putting up uh what was it? Option A. Yeah, cool. Let's go with option. Doesn't matter. So you guys can see that it has a proper root like .llmops folder, evals, prompts folder, config folder, then source folder, dashboard folder, logs folder, scripts. Then this is a external env file that it will create. And you can see this has proposed as the whole architecture design section, blah, blah, blah. And then this is the llmops.llmops, then source folder, then agents folder, pipeline logs. And the LLM ops part is natively baked right into the orchestration from the very beginning. And it knew that what has to be done. So let's cool and let's proceed. And we'll start decoding everything. Gateway single checkpoints, cool cost controls, pricing tables, soft limit, stage output, TTL, soft limit, hard limit, per request cap, pricing for open router model baked into the token counter.py. And yeah, I'm not going to code this, by the way, guys. This is a very short video just for you people to understand that this agentic skill file natively helps you bake the right LLM ops on top of your existing infrastructure or from the foundations when you are developing some things from the very start. And you will have complete control over whatever the costs you are incurring, whatever functions you want to run. You can use this in React, in Vue, you can do this in Python, you can do this in Angular, whatever language, it doesn't matter. And you can use GPT codex or Claude. You can, of course, paste this into the .claude file. Like if you have a folder like this, .claude, you can, of course, paste this file directly into the .claude folder and you can ask the .claude for Claude code or GPT, whatever, to take this file into consideration. You can put it under skills folder also and then you can do it. I know guys, you will be having a lot of skill files, so this is just one of them. After a lot of testing and research, this skill file came into existence, which is dynamic enough for you guys to, of course, you can tweak it, you can customize it according to your own infrastructure and according to your own needs and parameters. It is configurable enough. You can ask Claude to tweak these parameters in the skill file. It will do that, or cursor agent or whatever with table of contents. Cool. Yeah, this is it, guys. I hope you guys liked this video. And that's your observability, versioning, and analysis of LLM ops. This is a very short video. Yep. Until then, take care. Bye bye, guys.